Assalamualaikum warahmatullahi wabarakatuh. I am Putri Sasmita from Group 3. In this video, I will explain about plimpton 322. What is plimpton 322? Plimpton 322 is a Babylonian clay table, notable as containing an example of Babylonian mathematics. This table has a table of 4 columns and 15 rows of numbers in the cuneiform script of the period. The dimensions of the table are 8.8 cm by 12.7 cm. Plimpton 322 was first discovered in Iraq in the early 1900 by Edgar Banks, an American archaeologist, and was later purchased by George Arthur Plimpton in 1922. After Plimpton died in 1936, the table was donated to Columbia University. Henceforth, the table has been known as plimpton 322, signifying that is the 322 item in Plimpton collection. A table concerning number triple. In the 1940s, Otto Negebart, a historian of hygiene science at Bonn University, and his assistant Abraham Sands found that Plimpton 322 actually contains interesting mathematical content. The entries in the table are essentially Pythagorean triple. In the integer, solution to the equation is L the power 2 plus S the power 2 equal to D the power 2. The third column of the table shows the hypotenuse of a right triangle or diagonal. The second column shows S, the short side of a rectangle. The long side L of a rectangle is not shown. The first column in Plimpton 322 is the square of a region, which can be one of two interpretations, either the square of diagonal over long side or the square of short side over long side. This is the description of the four column. The decimal conversion of Plimpton 322. Bourne and Sachs found the fact to form a perfect triangle on the Plimpton 322 if the number in the column D are squared and once subtract from each of them the square of the corresponding number in the column O. A perfect square result. For instance, the first row contains the equation like this. Triple in the table are of special form. The third side can be expression U equal P the power 2 minus Q the power 2, L equal 2 times P times Q, P equal P the power 2 plus Q the power 2. This is the table. Babylonian as of the Pythagorean theorem. The Susa table was found in the present city of Susa in the Khuzestan region of Iran. The Susa table thus provides some of the oldest Babylonian examples of as the Pythagorean theorem. Table computes the radian r of a circle that circumscribes an isosceles triangle of side 50, 50, and 60. Application of the Pythagorean theorem this time to the triangle ADB leads to the equation. The Cairo Mathematical Papyrus. Cairo Papyrus discovered at Tuna El Gabel in 1938 and first examined by Parker in 1962. The Cairo Papyrus dates from 300 BC or possible earlier. In Cairo Papyrus, there are 9 problems dealing solely with Pythagoras' theorem. For instance, a ladder of 10 cubic had to spot 6 cubic from a wall. To what height will it rate? To problem deal with rectangles having area of 60 square cubic and diagonal of 13 and 15 cubic. Respectively, it is required to find the side. The first of the problem in modern notation, we have the system of equation. Right model of solution amount to adding and subtract 2 times x times y equal 120 form the equation x the power 2 plus y the power 2 equal 169 to get parenthesis x plus y the power 2 equal 289 and parenthesis x times y the power 2 equal 49 are equivalent with similar except that the square root of 345 and 105 are to be found. There are several methods for approximating the square root of a number what was not a perfect square. In this case, described as a formula generally attributed to Archimedes, which is also found in Babylonian texts. N equal a the power 2 plus b. To obtain square root of n, the first step was to form a square whose area a the power 2 was near to but smaller than n. The difference b equal n minus a the power 2 was viewed as the area of a rectangle with side of length a and b over a. Thank you for your attention. I hope this presentation has given us new insight on the table Babylonian Plimpton 322. Wassalamualaikum warahmatullahi wabarakatuh.